All right, here we go with the last lesson in Unit 8, and these are applications of radicals. It's basically one application, and it's the theorem that you've seen before and uses radicals, and it's called the Pythagorean Theorem. Okay, you have seen this. Maybe you haven't used it, maybe you've forgotten, but you are going to be using it here, and you're going to see how it applies to radicals. That theorem, if you've forgotten it, is a squared plus b squared equals c squared. Okay, this theorem can only be used with right triangles. If it's not a right triangle, you can't use it. The side that is opposite the right angle is called the hypotenuse. Identifying this side first is a good habit to get into. This is the longest side of a triangle every single time. Okay, the other sides of the triangle, the other two sides, are called legs. Okay, so that's some basics with triangles and the theorem. All right, so move on down. Find the length of the hypotenuse in a right triangle if the legs are 4 centimeters and 6 centimeters. Leave your answer in simplest radical form. Okay, so when I have a squared plus b squared equals c squared, c is always the hypotenuse. Always. All right, so I gave you the legs. I don't care which one's A, which one's B. It doesn't matter. So I'm going to say 4 squared plus 6 squared equals c squared. We don't know what it is. So now I just going to do some math. So 16 plus 36, right? 4 squared is 16, 6 squared is 36 equals c squared. Well, 16 plus 36 is 52. And now we have 52 equals c squared. This should look familiar. All the way back in lesson 1. How do I get rid of this squared? I have to take the square root. Square root of 52. I'm going to save us some time here. Leave it in simplest radical form. It is 2 radical 13 centimeters. Okay. So that's, what we're going to be doing. Now, I told you when I was talking about the hypotenuse that it's a good idea to identify the hypotenuse first. Sometimes I give you the hypotenuse, sometimes I don't. Okay, in this case, I did. The side across from the right angle is the 12. This is the hypotenuse here. So I gave you A and C. So when I'm writing my equation, I have 9 squared plus B squared equals 12 squared. A little different here than the one we just did. 9 squared is 81. B squared we don't know. 12 squared is 144. Okay, I'm going to subtract 81 this time. And I get B squared equals, what is that, 63? 63. And now I take the square root. Square root of 63 is 3 radical 7. So B equals 3 radical 7. Okay, number 2, quite a bit harder because there's radicals already there. The hypotenuse is 5 radical 13 though, right? Across from the right angle. I need a leg. So I have 5 radical 7 squared plus x squared equals 5 radical 13 squared. Notice I'm putting those in parentheses. Make sure you do that. If you don't put them in parentheses, you're going to get 35, which is wrong for 5 radical 7 squared. What you should get here is, let's see, 175. Now, let me show you why that's 175. 5 radical 7 squared is 5 radical 7 times 5 radical 7. Well, that's 5 times 5, that's 25. And radical 7 times radical 7 is just radical 49. But that's 7. 25 times 7 is 175. Okay. 5 radical 13 squared, very similar thing. You're going to get 25. 5 squared is 25. Square root of 13 squared is 13. So 25 times 13 is 325. And now I'm subtracting 175. And I will get what is that? 150. And then square root of both sides. Square root of 150 is 6. 5 radical 6. Sorry. Yeah. It's 5 radical 6. Okay. On the back, notice it says find the area of the triangle below. A triangle has the area. To get the area of a triangle, you have to do 1/2 base times height. Well, the base and the height are always perpendicular to each other. Perpendicular means they meet at a right angle. So my base and my height are 15 and x. So the area is going to be 1/2. The base is 15. Unfortunately, the height, I don't know. It's x. We need to go back and do the Pythagorean theorem to find x. So x squared plus 15 squared equals 21 squared. So x squared, 15 squared is 225. And 21 squared, I'm going to pull up my calculator here. And 21, oops, I'm annotating. 441, okay? And then 441 minus 225, right? Got to subtract 225 is 216. And then take the square root. And I get, I believe that's 6 radical 6. Just real quick, I'm going to check that. Yep, 6 radical 6, okay? So I still got to put that all together. So 1/2, 15, and 6 are all on the outside. So I'm going to multiply all those together. Radical 6, nothing's changing with that. 15 times 6 is actually 90, and 1/2 of 90 is 45. Now, that's the area in simplest radical form, okay? Now I want the area rounded, and it says round to the nearest 10th. So now I'm going to type that in the calculator. So I'm going to go back to the calculator. And I'm going to type in square root of 6 and then times that by 45. And I get 110.22, so just 110.2 units squared would be the label on that, but I'm not too worried about the label at this point. Okay, so there's another application, still use the Pythagorean theorem, but finding the area of a triangle. I got one more, and this one is quite a bit more challenging. However, I'm not going to test you on this, but it's good to see it. So we still got a right triangle, still using Pythagorean theorem. I want to find the value of x, which is a leg here, but I'm still going to use Pythagorean theorem. So 2 radical x squared plus 3 radical 6 squared equals 4 radical 5 squared. Well, 2 radical x, let me do that real quick. 2 radical x times 2 radical x is going to be 4 radical x squared. But what's the square root of x squared? It's just x. So this all becomes just 4x. 3 radical 6 times 3 radical 6 is 9 radical 36. And radical 36 is 6. So 9 times 6 is 54. 4 radical 5. 4 times 4 is 16. Square root of 5 times square root of 5 is 5. So 16 times 5 is 80. And look what happened. All the radicals went bye-bye and became a pretty easy problem. 80 minus 54 is 26. Divide by 4, I get x equals 6.5. If you want to leave it as a decimal or as a fraction, it would be 13 over 2. Okay, and that's it. Okay, that's all for Unit 8. Checkpoint A will be coming up soon. Yeah,